Hi guys, if you watched one of the videos, a couple of videos ago, I found some ITX motherboards at the car boot sale, 3 of them, yeah. They're actually inside point of sale units, and I've got rid of all the junk I didn't want, metalwork and stuff, but I've got 2 monitors, 19-inch monitors, ViewSonics off them. They don't have the stands, but you can put them onto a wall or something, VESA mount. I'll probably find one of the local hotels or bars, or one for the DJ booth or something like that. Yeah, most likely. So this is one of the ITX. This is the better of the 3, the more recent, if you like. And this one's working. I wasn't sure in the last video. I said it would flash the BIOS screen on, and I got a flashing cursor. But anyway, I put a hard drive on it, and it's working good. So I'll just show you what we have running on here now. So I've just put Windows on. I've put the drivers on, yeah, and I'll just get all the okay. So yeah, this one came with this processor, i5-3330, 3 gigahertz. It has a single 8 gigabit strip in, 8 gigabytes, sorry, which I checked is worth about over £20 actually. So there's a bit more profit to add to this job, yeah. Yeah, and there it is, all set up and working. Yeah, you can see the spec quite clearly, I'm sure. So okay, so we have one actually works, and we have 2 older ones that we need to look at. Just get the camera set back up, there you go. So with this working one, I'll just try 2 strips of RAM in, just to make sure both channels are working. If they are, then we can say this is a good one, yeah. And then we can have a look at the other 2. So the other 2 are these. They have, because I've taken the heatsink off one of them, they have an embedded CPU, yeah, which I believe some sort of Celeron or something like that. Somebody did say on the channel what it was. And they also said these are quite capable of running anything from Windows XP up to Windows 10 and up to 16 gig of RAM, yeah. Both of these have 4 gig on at the moment in 2 strips. Okay, so I'll use a couple of these strips to test this one in dual channel mode, and then after that we'll have a look at these and see what the problem is with them. Okay, yeah, that's good. So I've put the 2 strips in this off one of the other boards. The one that came out, Crucial, if you get the focus on it, you'll see it, but it's a Crucial 8 gigabyte DDR3 1600, so you know, quite a decent strip of RAM. I'm sure you'll find some use for that, or 20 quid or a bit more, something like that. Okay, so yeah, I've putting this back up. You can see now, so we've got again Specky's running, and this has now got so 4 gigabyte, yeah, 4 gigabyte dual channel, so it's working fine in dual channel mode. All the drivers are loaded, by the way. I used a USB with a snappy driver installer, and it has all the drivers installed, so we can say that is a good one. Yeah, that's a good board. So okay, let's start to look at the more interesting stuff. Yeah, let's have a look at the other ones and see what we've got there. Okay, so that was a bit of result. The first one was working, yeah, and that was the best of the 3 as well, so that's handy. So we have these 2, which are the same model, they're identical, yeah. They have, because I've taken the heatsink off this one, an embedded CPU built on the board, so you can't change the CPU. I've just put a little bit of heatsink compound on this one for now. So we'll stick this one back together, and then we can start, well, we can power them up and let's see what they do and see if we can figure out what the problem is with these, yeah. This is the first one of them. So let's just put a number 1 on this one and the number 2 on the other one, because it's very easy when you're working on 2 identical devices to get mixed up at some point, yeah, especially if you're swapping backwards and forwards between them. So we know which is which now. I'll take the RAM off this. I'm going to fit the RAM that we've just tested in the other motherboard, yeah, so we know these good. In fact, actually, I checked the manual I was looking at, by the way, and this is slot 1 and 2. So I think we'll just put 1 in for now. No, actually, no. Go on. We know we've got 2 good sticks of RAM. So let's just stick them in for now. Okay, so that's the RAM on this one. I can't see any speaker on this, and I had a look at the user manual and I couldn't see any mention of a speaker connection. So I know this is the power connection, but unfortunately there's nowhere to connect the speaker on it. Yeah. The CMOS battery I tested, and I believe I changed this one on the previous video where we were just sort of running a triage to see what with this stuff. Yeah. So this is the IKEA battery, so I've changed this one, and the battery's good. Yeah. I'm sure as well I actually checked for shorts. I did check for shorts on the 12 volt, but again we'll just do that. So ground, no, that's not a short, that's a resistance. Yeah. And the same into the other one. Okay, so we haven't got any shorts. So yeah, I think this one we'll just switch it on and we'll see what actually does. Yeah, let's see what happens with this one. So power's on, power supply, no, power's on now, power supply's on now. So let's start this one and see what happens. Oh yeah, this is the one that doesn't do anything. Now I seem to remember this, something was getting hot on this one. Switch it off again. I'm just going to switch this on now without trying to start it. Yeah, so it should just be in standby now. We can check that. So we should have 5 volt standby coming in here. Yeah, on the purple wire. So we got 5 volt standby. And I seem to remember that this one was getting, something was getting hot on this one. Yeah, it's down here. Something's getting, yeah. It's this voltage regulator here. This one is getting hot on this one. Let's see what voltage is on that, and then we can look at the other one as well. Yeah, so let's just go ground. What's on this regulator here? So it's 2 volts there, 5 volts coming in, and sorry, not even 2 volts, 0.2 volts going out. Yeah, so this appears to have a short or a heavy load on that. It's quite hot. It is quite hot. Let's just go on to resistance mode. So 5 volts was coming in here, and that was okay. I mean, 5 volts was there. Yeah, this is the output. No, it's 190 ohms. It's not particularly low. Let's get a good connection. That's ground. Just get, so make sure I've got a good connection. Yeah. So there's ground, yeah, 0.6. Now what resistance on the output? Yeah, 190 ohms. That's not particularly low, to be quite honest. Let's have a look at the other one. So what the other one does. As I recall, I think the other one boots up, well, powers on, but doesn't boot up. Yeah. So let's have a look at this one. So number one has got a regulator here getting very hot, that doesn't appear to have a short on the output. Yeah. And that's with just standby, so nothing should be getting hot if you've only got standby. Yeah, that should not be happening. Okay, so this one, then we'll power this on. Yeah, just before I actually start it up, let's have a quick look on the same voltage regulator. So, yeah, this is ground. This is the 5 volts coming in. Go to voltage range, of course. This is your 5 volts coming in. 5 volts, and what's coming out on this one? 2.1, 2.2, much higher. Yeah. Well, that's interesting actually. I thought this would be ground. So let's go again, and maybe I look for the short in the wrong place actually. 5 in, 2.2. Oh, that must be the gate, and this is the output. 3.4. Yeah. 5 points to 3.4. This will probably have a short on the output on the other one. Oh, and one of my cameras is frozen. One moment. Okay, I've unfrozen myself. Yeah, I'm moving. Okay, so let's again. We know what voltage is on that. While we've got this powered up, before we start comparing them, let's just switch it on and see what happens. Yeah, so power's on. Switch. And start it. This one has no RAM at the moment. I'm going to put the RAM in this as well. I should have checked all 4 of these actually while I had the other board. It's not a problem. Just the RAM in here. Okay. Power on. The switch is a bit heavy. Power on. Power on. There's no bleeper on this or anything. Regulator's pretty much cold on this, as you'd expect. I'm interested to see what. I'm sure this will have the same voltage on with it powered up. Oh, switched itself off. Switched itself back on again. 5. 3.3. But there's nothing on the screen. I don't have any signal. Oh, I do. This one, and it's gone off again. Let me show you what this is doing, yeah. So it's powering on. I've seen this problem before. It's powered off again, yeah. Powered on again. And what I saw at the top of the screen for a second, it said UEFI BIOS. Yeah, lights come on. Every second boot. Oh, this one's booted up now. This one's booted up. Let's see if we can actually get into the BIOS on this one, yeah. Okay, so I've just gonna plug it. I've plugged the keyboard in. World optimized BIOS, yeah. Defaults. Yeah, insert boot device. Okay, so this one looks like it might be working. Let's check the CMOS battery as well, because it did take a couple of times to boot up. And then let's just stick our known good hard drive on, see if we can get into Windows, yeah. Okay, so just power it off again, and we'll just. I'm interested to see if the battery's any good on this one. So ground, we're on battery volts. Yeah, that battery's no good. Yeah, 1.7. I mean, that's flat. I mean, these things have probably been lying around a long time, to be honest. Okay, so let's have a new battery in there. Okay, so nice new battery. 3.28, good. Power on again. Let's see if we can get into the BIOS again straight away this time, yeah. Where's my little start button here? And I'm sure you want to be seeing the screen as well, so power on. Blue lights come on, yeah. Oh yeah, went straight in this time. Okay, world optimized defaults and reboot, yeah. Actually, let's just go into the BIOS. Yeah, we're in the BIOS, so that's all fine. Save and exit. So if we get up to the right place, probably use the mouse, be easier. Oh, actually, the mouse is not plugged in yet. Mouse is not plugged in, don't worry about that. Save and exit. Save and exit. Yes. Okay, so this one then, I think we just need to basically get a hard drive, a good hard drive, and let's see if this will actually boot Windows. Okay, so yeah, it's booted into Windows. I've just running. I've used SDI, installed the drivers, and I've now just got Specky running. So you can see it's actually a 1.1 gigahertz Celeron 847. Notice it's only running single channel RAM at the moment, but both DIMMs are actually on the motherboard, so that's something we do need to have a look here as to why we only have single channel RAM running. Okay, so I've just shut it down, or it'll shut down in a moment itself. So yeah, I think these are the 2 strips of memory I had in the other machine, but I mean I could have mixed them up with these 2, I guess. Yeah, there it goes, it's shut down. Oh. Let's just try seating and reseating the memory a few times, yeah. I'll do the same with the other one. And if not, then we'll try one at a time in the different channels, yeah. So, I mean, it could just be a bit of dust in the sockets. Okay, that's reseated them a few times. Let's have a look now to see if we have both channels, yeah. Okay, yeah, that got it actually. So now we have 4 gig dual channel DDR3. Yeah, you quite often find that with motherboards that have been lying around a long time. Yeah, especially when these came out of point of sale units, they've probably got quite a bit of dust and they've been using like probably 12 hours a day or even more. Yeah, I mean some places up 24 hours a day. So that's not unusual. So what I'll do is now, while we've got this one working, let's just test the other 2 strips of RAM as well. Yeah, we know we've got 4 good 2GB strips here. So we can just be sure then, and we'll know whether or not we've got, you know, all this is good RAM. But yeah, this is we've got 2 out of 3 so far. But the other one has definitely got a fault on it. Yeah, the other one is definitely faulty. And so far we've got, if these are good, I think these are the ones we tested. I'm not sure, I might have mixed them up. If these 2 are good, then we've got 4 strips of 2 gig, which is not really of any great value, but they're nice to have. Yeah. Okay, so let's start this one up and let's see if this now detects again with these strips of RAM. Yeah. Yeah, so once again we booted and running Specky, and again you can see we have 4 gig, so we do indeed have 4 2 gig strips, which we've got plus the 8 gig. Okay, so that's good. So now I guess we're gonna have to have a look at the other one. Yeah, the one that actually isn't working. And let's see if there's anything we can do about that. Yeah. Okay, let's have a look. Right, we'll take all this off here then, and we'll basically now use these 2 boards to see if we can determine where the fault is on the other one. Yeah, it'll be useful. We can use this one to compare some resistances and hopefully find out where this assumedly short circuit is. Yeah, at the moment I'm assuming it's a short. So yeah, we can work that out hopefully, and having these 2 might just allow us to do that. Yeah. Okay, so that's everything all unplugged off that one. Make a little bit of space on the desk. Okay, so this is the one with the regulator that's getting hot. Yeah, down here. Just what the part number is. We'll have a look at the part number in a minute. So resistance mode. So now I know this is actually the output. I thought it was going to be a ground. We have a short there, 0.8 ohms. Yeah. And on the other one, we'll take the RAM off as well, so they're both in exactly the same state. Yeah. So on this one we have from here to ground. Well, it's high. 650 kilobytes nearly. So there's definitely a big difference there. Yeah. And we know from the good one, I'll just double check, I'm sure this was a 3 volts rail. We can power it up again and just check. I'm sure this was a 3 volts. This is now why you're at 1 and 2 on them, because I've already forgotten which one was which. Yeah. So we'll check the voltage again on this one to see what it is, and then we can effectively, from the bench power supply, we'll inject the same voltage onto the tab of this one, and let's see what gets hot. Because if it's drawing a lot of power, and our bench power supply can deliver quite a bit of power, something should get hot. Yeah, and tell us what the problem is. Okay, so this is the faulty one. I just checked to remind myself, and it was actually 3.3 volts that comes out at this regulator. Yeah. So there's the part. Let's have a look to see actually what part number this is. Yeah. Okay, so yeah, it's a little voltage regulator or something like that. I won't bother till we cut the part, because we basically know what the problem is here. Yeah. So what we have is coming into this voltage regulator on this pin. Yeah, is 5 volts, and it should have 3.3 coming out of here. And ours has a short circuit on there, so obviously it can't do that, and the regulator itself is getting very hot. But that won't help us to determine where the short circuit is. So what we do is, on the metal tab of here, we attach our bench power supply. Yeah, and then we can effectively control off the bench power supply how much current we send into this. Yeah, up to 6 amps on the bigger one I have. And once you've got the current flowing into here, whatever is short should get hot, yeah. If we're lucky, it'll be a capacitor somewhere or something like that. If we're unlucky, it'll be the PCH probably. Okay, so let's do that and let's see what happens. I find as good a way as any to do this is take a nice thick bit of wire, yeah, and just solder it to the tab of the device. I mean, you could hold a probe against it and inject the current, but if you do it this way, you've got both hands free, yeah. I think that makes life easier. It certainly does for me. So let's get a bit of a flux on here, and this should be quite easy to actually attach a wire to it. Bit of flux on there. Just melt a bit of solder on it. He says this is the easy way to do it. It's not, 'cause it doesn't want to take the solder. Huh. Okay, well, in this situation, there's other ways to do it, yeah? Well, let's have another go. Let's just see if I can get a bit of solder on the end of this thing here. Yeah, I got a blob of solder on it now. Okay, attach our big piece of wire to it. Yeah, under the hand, a bit underhand that was, yeah. Okay, so I can pick it up by the wire, so that's attached to that, yeah. We'll know if it's soldered on anyway, because we had a resistance to ground actually. It's about 0.3 of a volt or something like that. Yeah, 0.7 of an ohm, that's about what it was. Okay, so we've attached our bit of wire. Now let's get the bench power supply. I've set the output voltage here, yeah, to 3.3 volts. I'll just set it back again. So 3.3 is the known voltage of that rail, yeah. You should always set this to the known voltage or less, okay. Now we can set the current on here down to 0 initially, and obviously, well, we'll give it a little bit of current, otherwise this will be 0. I've just set it to a low current, yeah. Short the leads together. It's now set to a half an amp, so I can now dial in whatever current I want. Okay, and we'll set it initially to about 2 amps. You'll notice the voltage now drops to 0.2. That's normal because I've set it to 2 amps, so it has to adjust the voltage effectively to give the 2 amps, Ohm's law, yeah. So that will now deliver 2 amps into our board. The negative we can connect to somewhere on the chassis, yeah, and the positive we can connect to the wire that's soldered to the tab, which is where the short circuit is, yeah. And there we have 2 amps going into the board. Now I'm seeing now if something is going to get warm. If it doesn't, I'll turn the current up, yeah. I'm particularly just checking around this north bridge and around here, capacitors near to this regulator. Anything that is effectively, oh, and the current's gone off. Well, that's interesting. That's like whatever was short circuit has now gone open circuit. So by sending 2 amps through something, even though it didn't get hot, it effectively like caused the short to blow like a fuse. Does sometimes happen, not as all good while since I've seen that happen though. So all we can say is now is whatever was short now is no longer short, it's now open, yeah. Well, not is it quite open, it's drawing like 10 milliamps. Yeah, 0. So whatever was short now is just drawing a very low current. That's interesting. Well, all we can really do now is power this board up and see what it was. If it was something like the PCH, I mean, it might power on but just not boot, yeah. If it was something like a little capacitor or something somewhere, I might now just burnt that out to open circuit and it might work. Okay, that's interesting. Let's see what happens when we power it up. I mean, just to confirm that, by the way, I'm now on resistance mode. If we now check for our brown wire to ground, it was like 0.8. It's now kind of open. Let's go to ohms range itself, yeah. Do I have any resistance there? The other one was reading about 600 kilobytes. Is that what the other one was reading? That's interesting. Where's the other one? Remind myself. It was reading something like that. Okay, here's the regulator. Now that's interesting, isn't it? Let's power this board up and see what happens, yeah? I mean, just to show, I'm sure you know there's no skullduggery on this channel, but this is number 2, which I previously marked, yeah? And this is the one with the brown wire on, this is number 1. So the resistance off here now reads the same on both. What happens when we power it up? What do you think, guys? What do you think? Do you think this will actually now boot up and work? Or do you think it will start but not work? What do you think will happen now when I actually power this up? I'd take bets, but I can't, so can I say, not answers on the postcard, answers in the comments below, but even that I can't really say, because you can answer in retrospect, yeah, because any moment now you're going to see what happens, yeah. So we know we've got some good sticks of RAM. Maybe the slots are dirty. Okay, so that's on there. We need the monitor here. I'm not dragging this out or anything, by the way. I'm not. This is like the big moment of suspense, yeah, building it up, yeah. That's not deliberate. I'm not like doing anything here to like increase the view hours, yeah. You know, just to focus a little bit and just make sure everything's fine. Okay, right, so I think that's as much I can drag that out. So switch, yeah, on, yeah, power, and nothing happens. That's what hold on a second, hold on one moment, yeah, hold on one moment. Power, yeah, that, yeah, power, orange light on, yeah, still not dragging this out, and it still doesn't boot up. Well, that's interesting. I thought that might just like have started now. No, nothing. What voltage on our regulator now? Well, we can tell. We can test easy just on the end of this brown wire. Yeah, 'cause that's soldered to the end of it. Volts, yeah. 3.3. So we've cleared that problem, but it still doesn't work, which is a bit of a shame. But no, I've definitely got a good contact on there to be sure. I actually thought that had like about 50% chance of working. No, it's not like the fan's stiff or something stupid. Okay, yeah. I'm not sure how much we can go with that. I mean, obviously something burnt out. Yeah, when I did that, something somewhere has burnt out. I wonder if it may not be like I've burnt out the short, but there's a fuse link between this and whatever it provides, and like the fuse is gone. The only way to determine that probably is to see if we can find a schematic for this board, which sometimes for Gigabyte we can't. So I'll just go and have a look to see if I have a schematic for this, yeah? Okay, I actually do have a schematic for this board. And I've just had a look, so I'll show you what I found here, yeah? Let's go over to the desktop. So this is the device. It's actually a voltage regulator. L1117 is the actual type. I was at a different number, but that's what it is, yeah. So you can see it has 5 volt standby coming in, and on the tab on pin 2 is a signal 3V dual PCH, yeah. That's the signal coming out on both the tab and on pin 2, yeah. And that's where we had the short circuit, and now we don't. Okay, but it still doesn't work. So I just went in. I've already typed it in here into the search, yeah. So Control F to get the search into the PDF, and then I'm searching for it, yeah. And let's see where this signal actually goes to, yeah, because something was short, and I'm interested to know is what it might have been, yeah. So This is still on the same page, it's just picked it up there. You can see we're on page 13 of 13 actually, if I just scroll this over. Yeah, it's just found that and it's found that, so we haven't moved anywhere yet. Okay, that signal comes into this is the PCH, and it's there saying 2 milliamps. That must be the coverage it's supposed to draw. Yeah, goes into here. Now the question is this chip already, not already, is this chip connected to ground as well? Yeah, and the answer is, well, yeah, it does there to start off with, and there's plenty of pins on this chip that go to ground, yeah, directly. So is there a path to ground from here if there's a short in the chip? Yes, because there's ground available on the chip. Yeah, there could be a short to ground. Let's find where else it goes. So it goes to a capacitor. That could have been short, but if that had blown open, that wouldn't stop it from working. Yeah, just a capacitor. It goes here. Now this place, it goes via a resistor, so there's no path directly to ground. Resistors don't go short, they go open or they go high. So the short couldn't have been there. Yeah, there's no direct path for it. Where else does it go, this signal? 3V dual PCH. Oh, that's where we just were. So we're on the same page here. This comes via a resistor, so that could not have been the path, the short to ground. Yeah, R50 or this is a resistor as well. In fact, this seems to be an optional thing that may not even be fitted on the board, so I don't think the path to ground was down there. On this page, where are we now? Yeah, this is a capacitor. Yes, this could have been short to ground, but burning a capacitor out open wouldn't stop it from working. It's here. This comes through a resistor, so this is not a possible path to ground, so the short couldn't have been there. Where else? Oops. That's where we're. This isn't a signal. This is saying something in Chinese. I think this is saying something about the power sequence. I don't see the actual signal here. It's mentioned, but it's not like a signal on the board, so there's nothing obvious I can see there to say yes, this could have been short. Where else did it go to? Dual here, yeah, that's through a resistor, 8K, so that couldn't be a short. Oh, this is found a label up here, just saying there's a 10 millisecond delay after that signal was stable. Okay. Where else? Again, through resistor, no path to ground for it to be short. Through resistor again, so no possible path to ground there. Same through resistors, so no possible path to ground there. And that basically probably going to bring us back to where we started. Yeah, here again through a resistor. And we'll keep going round until eventually we come back to where it was generated. This goes through a diode, so unless that diode was short, we would have seen a diode junction, and we weren't even on diode mode, so it would have read open. And even then, this capacitor would have to be short as well. So I don't think that's where the problem was. Say I was on resistance mode when I was measuring the short, so that diode wouldn't even have conducted, so it couldn't have been there that was seeing the short. Here, no matter what happened to this transistor, there's no path to ground via resistors. Couldn't be there. And we're back to where we started. Yeah, page 13 of 31. This is where the signal comes from. So looking through that, the only possible place that could have been short that is now open is either going to be a capacitor, which honestly would not stop this from booting up. I'm 99 point something % sure of that, or the PCH, and the PCH would stop this from booting up. So I think it's extremely likely, just looking at the schematic there, apart from the fact PCH is much more likely to fail anyway, that this is probably where the problem is. We can take the top off. Let's get the heatsink off and let's have a look. Okay, so this is our PCH chip. I've just taken the heatsink off it. There's no heatsink compound on it, but if I just brush the dust off this thing, it does have a kind of like a conductive type pad on here. So I'm assuming that this wouldn't have a problem like with the lack of heatsink compound causing it to overheat. Let's just zoom down on it. Okay, I got the microscope instead. It was the easier way to do it. Oh, I'm here by the way. Okay, so I forget the torch. Let's have a look what this device actually is. Yeah, reflection of it. Oh, there we go. SLJTA. That'll probably tell us a lot actually. I'll get a piece of paper and I'll just mark these numbers. But we've got this E152C258. And then this SLJTA. Normally from that SLJTA we can actually find out what this is, yeah? Okay, so we can, okay, we go over to the desktop, yeah? And here I've just looked up, I typed in for SLJTA datasheet. Yeah, for one of the links was just eBay, and that tells us actually that this is what the thing actually is, yeah? So let's make a copy of that. So yeah, SLJTA Intel, that's what I actually search for, yeah, and it's finding quite a lot of links with this particular part number. Just out of interest, HM70 also is saying is the same thing. Let's go over to AliExpress and see if this is something we can just get, yeah. Come on, Ali. SLJTA, I'm on the wrong keyboard. SLJTA. Oh yeah, but they're yes, we can get them. Yes, they're rather expensive. I mean, price is coming down a little bit now. For the value of this board, for the possibility that will fix the fault, because I think something's burnt out inside. I actually believe something was short inside here, and then when I stuck a good 2 amps down it, just burnt out, whatever it was short. So the short's now gone, but it doesn't do anything, yeah? That's what I think's happened here. Okay, so yeah, we could get one, but I'm not really inclined to do that, just because of the cost of the parts versus what would the board actually be worth if I fix it, yeah? Okay, so I think we can actually say for good reasons this time. And if you've seen my videos, you know I'm not adverse to soldering BGAs, yeah? But I think in all honesty in this instance, I think we could probably say, look, you know, let's quit while the going is good, yeah? So we've got 2, yeah, good ones. I'm not sure how much these embedded ones are worth. I had a look on eBay and I could find somebody selling one without the RAM, just obviously the processor on the board, asking about £65 UK, yeah. I found others for sale, or had been for sale, but they were they were not available anymore, yeah, out of stock. Alibaba had them for sale new, whereas the other one on eBay was used, for about $60 in tens, yeah. So you buy 10 at $60 each. So supposedly that's what that board's worth. I don't know. The only thing is, when I found one on eBay asking 65 or nearest off, best offer, when I went into sold items, there weren't any. I could, not in recent times. Anybody actually sold one. I think that maybe the last 3 months. So maybe they have a value, but they're not particularly desirable. So I think, well, yeah, let's quit while the going is good on that one. And we've got 2 good ones out of 3, and I'm happy enough with that. Okay, guys, see you all very soon on another video. Ciao for now.